Hello and welcome once again. The discussion of this module will be based on functionals in R and which will also include higher order functions in R. The discussions of the previous module was primarily based on functional programming in R, including the concepts of closure of a function. The idea of functional and higher order functions are just the complement of what closure was actually. In this module, we will discuss about several inbuilt functionals that R offers us, like reduce, filter and many other things. And we will let you know about different functionals like lapply, maply and tapply from a slightly different point of view. So, let us see what is there in the store in the discussion of this module. Higher order functions, and since we are concentrating on R, so obviously unlike from a general point of view, here we will discuss more on the higher order functions that R offers us. From the previous modules, we came to know that R at its heart is a functional programming language, and hence this is not a surprise to know that the base package contains several higher order functions. Now, the basic question is, what does higher order function mean? Is it something which we have come across before, or is it something which is even more complicated? Let us start getting some ideas about this. Primarily, by higher order functions, we mean functions that take another function as an argument and then do something with that function. So, here a function is an input and a data object is the output. As we know from the previous discussion that in R functional programming, functions can be treated just like any other data types like vector or matrices. Like these data types, functions can also be passed around as arguments to other functions and returned by other functions and stored in lists. So, functions in R might not be as special as it is in other programming languages. It can be regarded as one of the many types and can be passed as an argument to some other functions. So, let us try to write down what we are actually saying here. Suppose we are considering a function fn. Here the way we are defining it is indeed very interesting. We are defining the function fn as a function of another function. So, here the function f is the input of the function fn. Also, along with f we can add any other argument and then we can calculate or compute the whole f. Now, as a special case, we can take up the function fn and then we can use the mean function, say for example, as an argument. Here we have x is equal to 1 to 50, that is the numbers based on which we want to calculate the mean. So, this is equivalent to the case if we use simple mean function in this case, and then within the mean function we just need to input the values 1 to 50. We all know this. Now, these two will give us the same result as it is given here. Additionally, here one thing that we want to mention is that we can include any argument within this fn function in addition to mean. Like simply in case of mean, we can include trim equal to something, which is obviously we know that it can be any number between 0 to 0.5. After seeing this example, you might be thinking that why do we need to use such complicated thing when we can simply use mean instead? The reason is that we can simply replace the function mean with any other and still can get the summary value effortlessly. Let's have a look at our next function. Here we are defining the add function, which is the sum of three numbers like x, y and z. So here we are using an user defined function. We can also use any inbuilt function here as well. Next, we are defining the function prod, which we can have by multiplying the three numbers x, y and z. Also, we are defining another function use, which takes a general function fun as argument along with others like x, y and z. This function fun can be anything. The use of function will work in such a way that it will apply the function fun to the other argument x, y and z and hence give the desired result. So, if we write the function use, then the function prod as argument along with other arguments like 2, 7, 23, it can be any number, then the output will be the product of the three numbers like the numbers we had given like 2, 7, 23 and it would be 322 as expected. Similar thing will hold for the cases if we use add as a function that can be used as an argument. Now, as we had started saying that there are a number of higher order built-in functions in R. So, they are reduce, filter, map, find, position and negate. Now, let's take them up one by one. Here we shall start the discussion with the reduce function. As the name suggests, it reduces a vector x to a single value. Now, how does it work? It works by recursively calling a function f two arguments at a time. So, basically it functions with the first two elements with the help of f, then combines the result of this with the third element and so on. That is why we are calling it recursive. So, whenever we write reduce, then within first bracket f comma 1, 2, 3, actually what R does is it takes f of 1, 2, comma 3. That is, at first the function f is applied to 1 and 2. Then again the same function f is applied to the resultant value of f of 1, 2 and additionally 3. So, now the argument is f of 1, 2 and 3. For example, if we take the reduce function and if the sum function then and the numbers b 1, 2, 3, these all might be taken as argument, then it will calculate 1 plus 2 is equal to 3 and then we will add 3 plus 3 is equal to 6 and hence the result 6 is obtained as it is shown here. Another name with which we can call a reduce function is we can call it with fold. So, the question is why this name? Because it folds together adjacent element in the list. Now, let us consider the problem from a slightly generalized point of view. Consider the addition function that has been given here. Here, as we can easily understand that we are initializing the output at 0. Then keep adding the values of x with output one by one considering all the values of x and hence we are having the final output, which is the sum of all the three x values. Instead of this, here the reduce function provides one higher order generalization. This takes an arbitrary binary operation as an argument as we have just seen, and as we know from the previous example, here we can rewrite the addition function as the one we have given here. Now notice that in the previous case we had done exactly the same thing using the reduce function. Here only we are just using a more generalized version. Using the product function instead of the sum, we can get factorial of any numbers. Like here we did this for 10. So reduce function has some more arguments that we can always explore. Like right is a logical argument indicating whether to proceed from left to right, which is the default one, or from right to left. Also, the argument accumulate is a logical one indicating whether the successive reduced combinations should be accumulated. Here by default only the final combination is used. Again, no match is a value to be returned in the case when no match, that is no element satisfying the predicate, is found. A predicate is a function that returns a single true or false, like is dot character, all, or is dot null, and so on. A predicate functional applies a predicate to each element of a list or data frame. There are three useful predicate functionals in base R, which are filter function, find function, and position function. We will take up the detailed discussion of these functions one by one. Now let us start the discussion with the filter function. This function is simpler compared to the reduce function. It simply selects the elements of a vector that match a predicate you pass in as a function. So now let us illustrate it with an example. Suppose we want to find the odd and even numbers from a set of numbers. We know that there are a number of ways to deal with these kinds of problem. So here we are presenting another one of these type. Now let us see how we can solve this using the filter function. Define the find.even.numbers, which is indeed a functional as it takes functions as arguments. Now what are these functions that they are taking? Here we are using it to be a function of x, and we are considering those numbers for which x is absolutely divisible by 2, and we are considering the set of numbers from 1 to 100 from which we are required to find the even numbers. So these sets are given. Similarly, the find.odd.numbers considers the function of x for which the remainder will be 1 when obviously x is divisible by 2, and again we are having the numbers 1 to 100 to look at. So here is the output corresponding to the function, and again we are having the numbers 1 to 100 to look at. So here is the output corresponding to the function. Now let us see how we can write some more complex function quickly. Here we are trying to find whether a given number is prime or not. So at first we have a function is.divisor, which is a function of b and x, and this will take care of the fact that if we divide x by b, then whether the remainder will be 0 or not. If it is 0, then the output will be true and false otherwise. Now we are using this function as an argument to construct the function is.prime. Here as it is a function of x, hence we are considering numbers from 1 to x. Now we keep on dividing the numbers by 1 to up to x. Among these, if for only 2 of the cases the remainder is 0, that is for 1 and the number itself, then we will consider that number as prime and else not. This is how we can get 23 as a prime number, as this is given here. We will consider the details of map and mapply when we will look at the apply family of functions. The next function find is a truncated form of filter. It locates the first item in a vector that satisfies a predicate, or it might be the last element if right is equal to true. Now let us consider another example. Suppose we want to find the prime number greater than some number, say 50. Then what do we do? Remember, we have the is dot prime function that was just defined a while ago. Use this along with the find function. So let us see what happens. Now if we put the function is dot prime and numbers 50 to 100 within the filter function, then the output will be 53. So what actually is happening here? Primarily, unlike the is dot prime function, which will only tell us whether a particular number which we are interested in is prime or not, this function will start finding the prime number from 50 onwards, as the range given is 50 to 100. Now, whenever a prime number is obtained, the output will be shown and the function will stop working. Similarly, if you just put right is equal to true here as an additional argument, then it will start finding the prime number from the right, and here is the output, which is 97 here. The basic logic behind finding a prime number obviously remains the same here. So let us see what happens when we just put a number unlike an interval as an argument of the function that is find. Let us put the number 50. Since this is not a prime number, so the find function is unable to find anything, and hence we are getting the output to be null. As against, if we put a prime number 53 as an argument, we will end up with 53 as an output. Another function of this type is the function position. Position has a lot of similarities with the find function. The only dissimilarity is that position provides the index of the element that would be returned by find instead of its value. Here we are using the exactly similar example that we just have considered for the function find. Unlike the find function, if we want to find the position of the prime number starting from 50 going up to 100, then the output will be 4. This is simply because of the fact that 53 is the desired prime here and it is in the fourth position starting from 50. Similarly, for the second command, starting from right, the prime number between 50 to 100 is 97, as we had seen previously, and this is in the 48th position if you count it from the beginning. Hence, we are having 48 here. Again, here also, since 50 is not a prime, so the position is given to be not available here. And if we consider the prime 53 only, then 1 is shown as the output, although it does not make much of sense here. This is the function negate. It simply flips the Boolean sense of an existing predicate. So the idea is, suppose a predicate function f is given. It creates a function which returns the logical negation of what f returns. Here we are aiming to look at whether a given number is composite or not. So as we know, a composite number is a positive integer that has at least one positive divisor other than one or the number itself. In other words, a composite number is any integer greater than 1 that is not a prime number. So, we have the idea now. So, primarily we are trying to get the numbers that are not prime, and hence we are negating the function is dot prime. And what we find is that 23 is not a composite number, since it is a prime number as opposed to 26, which is not a prime number, hence this is a composite number. So, as I stated in the very beginning, all of you are familiar with some kinds of functional. The three functionals that are used most frequently are lapply, apply and tapply. All these take a function as input among other things and return a vector as output. That is why this is called functional. We started knowing these apply family of functions in our earlier modules, but in the next few modules, starting from these as well, we will look at these kinds of function from a different point of view. We will come to know how the functionals can be used as an alternative to for loops. Now, the question is, why do we avoid for loop? During the recapitulation of basic programming issues, we already mentioned the fact that for loop is really very slow, though there are some debates regarding this issue. So, we will take up this matter in the next module, and we will discuss the ideas of lapply, apply, tapply, mapply and some other functions from a different point of view in the next module. So, in this module we had some basic discussions about what functional actually is and what is higher order function in R. We came to know that there are some basic built-in functionals in R, which are filter, reduce and many more. We had some detailed discussion regarding this function. At the end of the discussion, we just started about the discussion of the apply family of functions like lapply, mapply and tapply. We will continue this discussion in the next module, and so we will come to know that what different kinds of functionals are there in R. So, we will see this in the next module.